transformations, translation, rotation, and scale. So to translate the UV map, we add a displacement vector. And this same vector is applied to the whole UV map. And doing this, we have the UV map translated. I start with a 3D scene, a mesh instance, a plane, and inside a shader material and a new shader. I'm going to call it translation. So I first assign the UV map to albedo. It has to be a vectoric variable. Then I add the displacement vector to the UV map. As you can see, the UV map has been displaced. Now I can add animation to the displacement vector with the help of the sine function, with a range of movement from minus 0.5 to 0.5. Now, I am going to use a feature of GODOT 4 that are the shader preprocessor directives. In order to do that, I have to create a new file with extension GDShader Inc. And inside, I'm going to copy the poly function, the polygon function. And there is a problem with the global variable tau that doesn't exist in the include file and gives us an error. But we can ignore that because at the moment of including the file in the shader, the global variable is included anyways, so the error disappears. We use the directive, and now we can use the polygon function. So we add the transformed map to the function and show the poly in albedo. Now, in order to make the rotation, we have to multiply the UV map by a rotation matrix. The components of the rotation matrix are the basis vectors x and y, which are rotated by trigonometric functions. As you can see, each basis vector has its x and y coordinates. So we have the x and y coordinates of the basis vector x and the x and y coordinates of the basis vector y. In a previous tutorial, I explained how to rotate a vector and get a rotation matrix. In Wikipedia, you can see the rotation matrix. It's a little different because the orientation of the UV map in GODOT is different, and also the positions of the basis vectors are different. They are horizontal and not vertical. In GODOT shaders, we also have a different rotation matrix, but I am going to use my own version of the rotation matrix because it makes more sense to me. You can use the GODOT shaders version if you want. When rotating, we have to define the pivot point where the rotation is going to be done. Usually, we will use 0.5 so that the rotation is at the center of the UV map. So I am going to duplicate the plane and select Make Unique Recursive. That way, I get both the material and the shader to be unique as well. Next, I will save the shader as rotation GDShader. Now I delete the content and I leave the include directive unchanged. And I will define the rotation function using the rotation matrix that I mentioned before. After that, I subtract the pivot, then multiply the UV by the matrix, and then add the pivot again, and then return the UV map. I assign the rotation to a new UV map. Create the poly variable. But first, I am going to show the UV map in the albedo so we can see the rotation. There you have it. Now I create the float poly variable using the polygon function, and I assign this to albedo. Scale is much like rotation, but the matrix is different. You can notice that the matrix is close to the identity matrix. Just two values change: the x component for the x basis and the y component for the y basis. This time, the pivot point is mandatory. It's not optional as in the case of rotation. So I am going to duplicate the plane again and make it unique, recursive. Next, save the shader as a scale GD shader. I'm going to delete the code for rotation and just copy and paste the scale function. I just subtract the pivot and then add it again. I delete the code inside the fragment, and I create a new UV scale variable, vec2, and save the result of the scale. I'm going to animate the size with the apps function and sine, so I get values between 0 and 1. You can see now the result of scaling of the UV map. Now I create the poly with the polygon function and the UV scale map, and assign it to the variable albedo, so you can see the output.